Today we're going to be factoring, and specifically we're going to factor out a monomial from a larger polynomial, and we do this by finding the GCF. Okay, so let's start with some definitions first. So you have the word factor, and factor is just any number that evenly fits into another number. So for example, the factors of 20 are 1, 2, 4, 5, 10, and 20. And these are factors of 20 because 1 times 20 is 20. 2 times 10 is 20. 4 times 5 is 20. But there are no other numbers that are factors of 20 because they don't multiply to 20. So let's take 3 for example. If you do 3 times 6, you get 18. If you do 3 times 7, you get 21. But you can't multiply 3 by any number to get 20. So 3 is not a factor. Okay? Now the greatest common factor is the largest factor that is in common to two numbers. And we call this the GCF. So just like before, I listed all the factors of 20, 1, 2, 4, 5, 10, and 20. And the factors of 16 are 1, 2, 4, 8, and 16. And the factors that are common to both of these are 1, 2, and 4. And that's it. Those are the only three numbers that are factors of both 20 and 16. So for the GCF, we're just looking for the biggest one, the largest. So the greatest factor is 4. So we call it the greatest common factor. Now, sometimes you're gonna have to find the greatest common factor, the GCF, of variables. So you're just always gonna choose the one with the smaller exponent, right? So I gave this example, the GCF of x to the fifth and x cubed is x cubed because 3 is smaller than 5. You would do that with anything. If I wanted the GCF of x to the 7th and x to the 6th, well, that's going to be x to the 6th because 6 is smaller. So you just always go with the smaller exponent. Okay, and factoring, so those are what like factors are, but we use factors and the GCF to then factor a polynomial. It's kind of the reverse of multiplying, right? So let's look at this example. So the first piece is asking you to distribute. So if we were to do 3x squared times 4x cubed, I would do 3 times 4, which is 12, and 2 plus 3, which is 5. 3x squared times negative 10x squared, well, 3 times negative 10 is negative 30, and 2 plus 2 is x to the 4th. 3x squared times x, well, there's an imaginary 1 here, so 3 times 1 is 3. It's positive, so I'm going to add it. And 2 plus 1, because there's another imaginary 1 there, 2 plus 1 is 3. And last, 3 times negative 5 is negative 15, and keep that x squared. Right, and that should look like the next question, but the next question is the opposite. It's asking you to factor it now. So if you were to go backwards, you're now going to first look at all your numbers and find all the coefficients, right? And try to find the greatest common factor. So one thing I like to do is I actually like to start with the smallest number and find all the factors of that. So all the factors of 3 are just 1 and 3. So that must mean one of these, right? 1 is a factor of everything. We just need to figure out, is 3 a factor of everything here? And it is, right? So we know we can factor out a 3 because 3 evenly fits in 12, 30, 3, and 15. And now we want to find the GCF of the variables and their exponents. But like we said before, it's always the smaller exponent. So the smallest exponent here is x squared. Okay, and I'm realizing there is a typo here, but I'm just going to roll with it. 3 times 4 is 12, and 2 plus 3 is 5. Keep going. Minus 3 times 10 gets you 30. This was supposed to be a 4, right? So I'm just going to change that real quick. Okay, and then 2 plus 2 is 4. Go on to the next one. We got plus 3 times 1 is 3. And 2 plus 1 is 3. Minus 3 times 5 is 15. And I already have my x squared, so I don't need any more x's. Right? So all I did here is go backwards. So for distributing, you know what's on the outside, and you multiply it by everything on the inside. For factoring, we want to figure out, well, what could we multiply everything by to get this thing? Okay? And I don't know why that's moving with it. There we go. Okay, so here's some practice. I'm going to do these practice questions. This is not your assignment, but this is just going to be something you can watch to see some examples of. Okay, so for number 1, I'm looking at my smallest coefficient, which is 3. My factors of 3 are 1 times 3, and 3 also goes into 9. So I'm going to factor out the 3. 9 does not have an r, so I can't factor r out. So 3 times r is 3r, plus 3 times 3 is 9. Okay, number 2. Look at your smallest coefficient, that's 2. We got 1 times 2 here. Those are the factors. So, and 2 also goes into 16, so I know I can factor out a 2. Okay, both of these terms have a variable, and the smallest exponent of that variable is 3. Great. So now 2 times 1 brings me back to this 2. So it's 1n. I already have a 3, but I need 5. So I know this has to be squared because 3 plus 2 is 5. Plus, I have 2. I need 16. 2 times 8 is 16. And I already have an n cubed that we're going to be multiplying by, so I don't need any more n's. And that's that. And remember, you don't need that 1 here. I tend to not write it, but you can leave it if you want. Okay, question 3. Again, let's look at our smallest number. So in this case, it's 18. It's a little larger than the ones that we've seen so far, but that's fine. So we got 1 times 18. I like to go in pairs. That's my best way. You can also divide. Just do like, try 18 divided by 1, 18 divided by 2, 18 divided by 3, and just wait to see which one divides nicely. Okay, but we got 1 and 18. We got 2 and 9. We got 3 and 6. 4 is not a factor. 5 is not a factor. 6 is a factor, but we already have it listed, so we're done. Okay, so now we want to find the largest factor that goes into both of these. And for this, you might actually have to write out the factors of all of them if it's not immediately obvious. So let's do it again. 1 times 24, 2 times 12, 3 times 8, 4 times 6. And since we're almost done, might as well. 1 times 21, 3 times 7. I think that's it. So if you look at our ones that repeat, we got 1, 1, and 1. And 1 will always repeat, so that's not one you're going to want to choose. 2 is not a factor of everything. 3 is. And that's it. So we know our GCF has to be 3 because it's the biggest factor that goes into all of them. Okay, so factor out that 3. And we can't factor out an n because 21 doesn't have it. Okay, so now we think about if we were to distribute. We have 3 and we need 18. We know 3 times 6 is 18, and you need n cubed. Minus, we have 3, we need 24. 3 times 8 is 24, n. Minus, we have 3, we need 21. 3 times 7 is 21. And let's do one more example. These are also quite large numbers, so do exactly like what I did in the last one in number 3. List out all the factors if you need to. However, looking at this, well, I know that 8 and 10 are factors of 80 pretty quickly, right? Because 80 is a multiple of 10. And 72 is just 8 less than 80. So 8 times 9, 8 times 9. So I just looked at that pretty quickly and realized that 8 is a factor of everything. So I'm going to factor out an 8. And now I'm going to look for my smallest exponent, which is a 2. So 8x squared. And now again, we go term by term. I have 8. I need 72. And I know that 8 times 9 is 72. And then I need 5. So 2 plus 3 is 5. So x cubed. Minus, we just did that. We know this is 9. I have an exponent of 2, but I need 3. So I only need 1 here because 2 plus 1 is 3. Right, minus again. I have 8. I need 80, so I need to multiply by 10. I need x squared, but I already have x squared here. So we're done. Okay, and that is how you factor out a monomial from a polynomial.